Hello and welcome to section 10.4. Today we're going to look at something called space figures. By the time we're done with this, we should be able to identify common space figures and then identify space figures from what we call nets. As you can see here, we have two space figures. The one here on the left is what we call a prism, and it's called a prism because it has two parallel bases. So these bases are going to be right up here. So this, I'm going to put B for base, and then this face down here is also a base, and they're parallel to one another. And they're also congruent, meaning they're the exact same shape as one another. So we have two parallel bases that are congruent. And then it says the lateral faces, or the faces that are connecting them, okay, are parallelograms. So if you notice, if we look at like this right here, this face, as is all the other faces, are all parallelograms. So that is the definition of a prism then. Over here on the right, we have what we call a pyramid. And a pyramid says it has a base that's a polygon. So you can see right here, we have a polygon base, and it looks like it's a 1, 2, 3, 4, 5, 6. So that would be a hexagon. And then each of the lateral faces are triangles. So those would be these faces right here. And they do that all the way around. They're going to form triangles. So that's what makes that a pyramid. The next two space figures that we're going to look at is called a cylinder. And you can see that the cylinder is here on the left. Okay, a cylinder is a space figure that has two parallel bases, and more specifically, those bases are what we call congruent circles. So you can see down here we have a base that's a circle, and this base up here is a circle. So because they're both circles and they're the same size circle, that means we have a cylinder. And the last space figure that we're going to look at is what we call a cone. A cone has one circular base, and then it has one vertex. In other words, it's going to come to a point, kind of like an ice cream cone would. There is one more space figure, and I forgot to put the picture on here, but we'll cover it just in case it comes up in your homework. But one more type of space figure that you're going to see is what we call a sphere. Okay, and a sphere looks something like this, so it's nice and round. Okay, and then through the center we get this circular shape. If we could slice that in half, this does have a radius r, and by definition a sphere is a set of all points in space that are a given distance from a given point called the center. So no matter where you go on that sphere, you're always going to be a set distance from that center in the middle there. So let me get a pencil here. We could come over here and these would be the same distance. Or if we come up here, this is going to be the same distance. Or over here, these are the same distance to that center. And I'm sure you have way better drawings in your book. So just in case you encounter them, this is what a sphere is. Now let's go ahead and take a look at a couple examples. Example 1 says, for each figure, describe the bases and name the figure. So for part A, the thing that I notice is I see that we have two bases that are parallel and they're the same size. Okay, so if I look at this end here, that's the exact same shape as this end down here. So I know that based on that, we are going to have two bases that are parallel, and we'll write that out. So two bases that are parallel. And if you notice, the connecting sides or the lateral faces which the lateral faces are going to be these right here, and then you can kind of see it going on the back, and then you got one down here. Those are the lateral faces. Those are all parallelograms. So those, because my bases are triangular and they're connected with parallelograms, this tells me that I have some type of a prism. So specifically, the type of prism that we have for example 2, it says name each figure. So when we look at part A, we can see that we have a circular base on the top and a circular base on the bottom. So because we have circular bases, this tells me that we have what we call a cylinder. And when we look at part B has a circular base down here in the bottom, but that circular base is actually going to converge to a vertex. That tells me that we have a cone. So this one here is a cone. And that's exactly what we have to do to name our space figures. For example 3, number 1, I notice right away I have this square base, and I know it's square because I see that each side length is 10. And then I also notice that my sides here are all forming triangles. So because those form triangles, that tells me that this here is going to be a square pyramid, because the base is a polygon and the lateral faces are triangles. When I look at number 2, I have 2 parallel bases, and those would be right here. Those parallel bases, if you notice, we have 6 sides, so these are hexagons. And all of the lateral faces, which run this direction, these look like those are parallelograms. So because we have parallelogram lateral faces and 2 bases that are hexagons, this right here is going to be a hexagonal prism. For part 3, okay, again I'm going to look to see what the base is. And here I can see that my base is a triangle. Everything is converging up to a point, and the lateral faces are all triangles. So this would be a triangular pyramid. And last but not least, number 4. Now with this problem here, it doesn't matter. You have a couple different faces that you could use for bases. So for me, if I use like this face up front and then the one back here, I notice both of those are rectangles. You could have technically maybe used like this face here and this face in the back, which are also rectangles. Or if you wanted to, you could use the face on the top and the face down here on the bottom. It doesn't matter. All of these are rectangles. So because all of these are rectangles that we have for faces, or bases, sorry, and the lateral faces are all parallelograms, this is what we would call a rectangular prism. And that's how we do these types of problems. Now the last thing we're going to look at is what we call a space figure from nets. So a net is a pattern that you can form into a space figure. So I kind of like to think about this as if this were a piece of paper. You could actually fold this and create like a paper space figure. So when you have to name one of these, what I do is I always try to identify the base, and then I think it makes it easier to name it. So like the case in part A here, I notice right away that we have a base because all those sides are connected there. And my base is a hexagon. And then I have all these little triangles that are connecting to it. So if I were to take these triangles and kind of fold them up along these lines here, then what that's going to do is that's going to allow all those triangles to come up to a point. So once they come to a point, I know that I have a type of pyramid. And then because I have a base that's a hexagon, I will have a hexagonal pyramid. Likewise, when I look at part B, with part B, I see that I have two triangles and everything else is the same shape. So the two triangles must be my bases because they're going to be parallel. And if you notice, these two triangles, they are opposite ends from one another. So these are going to be my bases. And then I'm going to have these three lateral faces. So here's one, here's two, here's three. And again, if you kind of treat those vertical lines right here as like folding points, if you folded all of those, this right here would create a triangular prism. So let's take a look at our last example and see if you can do that on your own, and then watch the video and we'll walk through the explanation. So example 4 wants us to name the space figure. So when I look at part A, again, I try to find the base. So for part A, I see that I have 3 outer triangles connected to one central triangle here. So because my base is a triangle, and I can see that my 3 lateral faces are also going to be triangles, I see that we have a triangular pyramid. And for part B, if we look at this, I see that I have parallel sides, or what could be a parallel side. So we'll say right here and right here, because these are attached on opposite sides there. Those are both, they look to be pretty square, so we'll say they're squares. Then for our lateral faces, we have 1, 2, 3, 4 lateral faces that are also squares. So because everything has the exact same size and shape, I'm going to say that this is what we call a cube, or you could say it's like a square prism. But a square prism is really what we call a cube. Please let me know if you guys have any questions. Otherwise, I hope you guys have a great day.